Okay, so we're solving four of the problems from exercise 6D, which was problem solving using linear equations in one variable. And so we're going to make sure that we solve all of these problems using only one variable. I know it's possible to do some of these with simultaneous equations, but that's not going to be our approach today. Let me just make my view ever so slightly different, maybe 100%. And there we go, now I can see everything a bit more clearly. So, whenever I read a word problem, I go right to the very end. How old is Heidi now? And so the question's really asking us then to establish Heidi's present age. So let's define our variable. Let x be Heidi's present age. When Heidi was born, her mother was 21 years old. Well, that must mean that her mother is 21 years older. So what's 21 years more than Heidi's age, x? That must be x plus 21. And if you were solving this with simultaneous equations, I suppose you could say let y be Heidi's mother's age, and then x plus y would be, y would be equal to x plus 21, and you could build two equations involving two variables and solve it that way. But I want to do this with just one variable in today's lesson. Now at present, Heidi's age is, so here's Heidi's age, is 30%, let's think about 30%. 30%, that means 30 for every 100. And if I write that as a decimal, that's 0.30. So x is 30% of, that means, the word of means multiplied, of her mother's age. 30% of times x plus 21. And now we've done the hard work, we just need to solve this linear equation. Let's start by distributing on the right-hand side so we don't have any parentheses. And now I'll bring the x's together on the left. So if I subtract 0.30x from both sides, I'm left with just 6.3 on the right. And if I divide both sides by 0.7, I find that x is equal to 9. So that must mean then that Heidi at present is 9 years old. And that of course must mean that her mother, who is 21 years old, is 30, but the problem doesn't ask us for that. Now I should probably just do a check. So if I substitute in my x equals 9 into this equation, is it true that 9 is equal to 0.30 times 9 plus 21? I've just substituted into here. So let's resolve the right-hand side. 0.30 times 30, and that gives us 9. Oh good, so it is true, and therefore I've validated my response. Heidi is 9 years old. Question number 8. Young has 50 stamps. We're being asked how many 2-cent stamps does he have. So let's immediately define the variable. Let x be the number of 2-cent stamps. Now he's got 50 stamps which are either 2-cent or 5-cent values. So we have to come up with some sort of expression for the number of 5-cent stamps. Is the number of 5-cent stamps. So what have we been told? Well, he's got a total of 50 stamps, and x of them are 2-cent stamps. Well, how much are left over? So if this confuses you, you can always substitute in a few test values so that you can see what's going on. Let's suppose that he's only got 3 2-cent stamps. Well, then how many 5-cent stamps would he have if he has a total of 50? Well, he'd have 47, right? What did you do? Well, you took 50 total stamps, you took away those 3 2-cent stamps, and that left you with 47. Let's check that again. Suppose that he's got 20 2-cent stamps. We take those away. Yes, that does leave us with the remaining 30 5-cent values. So in general, we need to take away the number of 2-cent stamps in order to find the number of 5-cent stamps. And the total value is $2.02. Let's convert that to 202 cents. So we've got the value of the 2-cent stamps, which is 2x. Now let's just think about this. If you had 7 2-cent stamps, what would be their total value? Well, you'd need to multiply it by 2, right? Or if you had 13 2-cent stamps, what would be their total value? You'd need to multiply it by 2, right? So in general, if you've got x 2-cent stamps, what is their total value? It's x times 2, which we can write as 2x. And so 2-cent value times the number of coins of that value, plus the 5-cent value times the number of coins of that value, must equal the total value in Young's stamp collection. So let's now solve this by distributing the 5, grouping the x's together and bringing the 250 over to the right, and then dividing both sides by -3 to get 16. And so let's just perform a quick check. So if we had 16 of these 2-cent stamps, that must mean that there were 34 of the 5-cent stamps. And let's see what this gives us. 32 plus 170, that equals 202. Look at that, it worked. And so we can conclude definitively then that Young has 16 2-cent stamps. And if the question was asking us for both numbers of stamps, well then of course we could conclude that he has 34 5-cent stamps. Jump to number 10. Carlo has 35 stamps. Some are valued at 2 cents, some are valued at 5 cents, some are valued at 10 cents. So let's define those variables straight away, because if I look at the end, how many of each stamp does he have? So let x be the number of 2-cent stamps. Okay, I need some expression in terms of x. If I want to solve this question with only one variable, so I'll leave a blank. Let something be the number of 5-cent stamps, and let something else, we'll see in a minute, be the number of 10-cent stamps. Right. Now let's look at the details in the problem. It says here that he has 3 times as many 5-cent stamps as 2-cent stamps. So he's got 3 times more of the 5-cent stamps. So the number of 5-cent stamps must be the number of 2-cent stamps times 3, giving us a total of 3x, triple the number, 3 times as many. And we also know that he has a total of 35 stamps. So that must mean, like using the same principle as before, that 35 minus the total value, the total number of the other stamps would be the total of 10-cent stamps. So he's got to first subtract the number of 2-cent and then the number of 5-cent stamps, and then he'll be left with the number of 10-cent stamps. So that's going to be our expression. 35 total stamps, and if we take away both the x and the 3x, it's 35 minus 4x represents the number of 10-cent stamps that are left in his collection. And now we know that the total value of all stamps is 189 cents. So, like in the previous problem, the 2-cent stamps are multiplied by the number of 2-cent stamps. That gives us the total value of the 2-cent stamps. And then our 5-cent stamps, we've got 3x of them. And then the ones that are worth 10 each, we've got 35 minus 4x of them. And the total number of cents that this is all worth is 189. And now we'll solve. 2x plus 15x. Distribute over here. And now let's collect the x's together. 17 of them minus those 40 of them leaves me with negative 23x. And the 350, I'll bring it over to the other side, becomes a negative 350. And now we need to divide both sides by negative 23. So this difference right here is negative 61, divided by negative 23, and that gives you an answer of, positive 7. And so we can conclude then that we have 7 2-cent stamps, and we've got 3x, 3 times as many 5-cent stamps, and we've got 35 minus 4x. Well, you know what, it might be easier to think of this as if we've got a total of 35 stamps and I've already used 7 plus 21, 28 of them, then I guess there's only 7 left in the collection. 7 10-cent stamps. And if I do a quick check of my work, I'll substitute these values into the original. So if I've got 2-cent stamps and 7 of them, and I've got 5-cent stamps, 21 of them, and I've got 10-cent stamps, 7 of them, let's just see what we get. 14 plus 105 plus 70 equals 189. It's exactly what I expected, so yes, this validates my answer here. And last question, number 11. Tickets at a football match are $6, $10, or $15. How many of each type of ticket were sold? So let x be the number of $6 tickets. Let some expression be the number of $10 tickets, and some other expression will be the number of $15 tickets. Let's look at the information then. The number of $10 tickets sold was 3 times the number of $6 tickets sold. So we had x $6 tickets being sold, so 3 times that number must be 3x, just like the last problem. And we also know that the number of $10 tickets sold was 500 less than the number of $15 tickets sold. So this quantity must be 500 less than this quantity. Well, that must mean that this quantity is 500 more than this one. And now you can see, look, this one is 500 less than that one. And now we're ready to do the last step. If the total gate receipts was $84,450, so our $6 tickets times the number of them, our $10 tickets times the number of them, the $15 tickets times the number of them, which we know is 500 more than the $10 tickets, and that's your total value, because each of those expressions represents the total value of their respective dollar value a ticket, and here's your total value when you add them all together. So let's simplify the left-hand side, and the 15 will distribute, and now I'll group my x's together on the left. I've got a total of 81 of them, and if I bring the 7,500 to the right, it becomes a negative 7,500, and so now let's divide both sides by 81. I'm going to have to use the calculator here to help me. 84,450. If I subtract 7,500, then I've got 76,950, which I'm dividing by 81. So let's divide that amount by 81, and we see that we've got 950 tickets worth $6 each. So therefore 950 $6 tickets, 3 times the number of that, we know that we got 3 times as many $10 tickets, so we can see that's 2,850 $10 tickets, and of course we can subtract that total to end up finding the total number of $15 tickets, but I'll leave that for you.